You're looking at something that should not exist. A cosmic ghost hovering in the dark. Caught in a terrifying purgatory between two distinct states of reality. It's not a planet. But it's not a star either. And as the James Webb Space Telescope recently peeled back the dust, no. To look at this anomaly, astronomers realized something chilling. The universe has been hiding monsters, right on the edge of ignition. Now, imagine staring up at our night sky, expecting to see the familiar, comforting glow of distant suns, only to realize that the darkness between them isn't empty. It is filled with colossal, silent giants. Objects so unimaginably massive that you could fit 15 of our Jupiters inside them, yet so cold and dim. They emit almost no visible light. For decades, we thought the line between a planet and a star was absolute, a boundary of physics. You either gather enough mass to crush your core and ignite the fires of nuclear fusion, lighting up the void for billions of years, or you don't. No, you remain a dark, wandering sphere of gas. But this boundary is crumbling. Because hovering out there in the deep expanse of the Cygnus constellation, there is an object that walked right up to that boundary, gathered the apocalyptic pressure needed to spark a sun, and then somehow stopped. It is a failed star, a heavy, brooding titan that holds the mass of a stellar furnace, but breathes the cold atmosphere of a planet. And what scientists just found buried deep within its chemical signature isn't just rewriting our understanding of how stars are born, it's warning us that our galaxy might not be teeming with these silent leviathans, and we are only just beginning to find them. To truly comprehend the terrifying scale of what the James Webb Space Telescope just found hiding in the dark, we first need to understand the fundamental rules of the universe. It just broke. We need to understand the absolute boundary of light. Let's start with something familiar. Picture Jupiter. Jupiter is the undisputed king of our solar system. It is a colossal, swirling sphere of hydrogen and helium, so unimaginably massive that you could take over 1,300 Earths and drop them into its chaotic atmosphere, and they would simply vanish. If you were to combine the mass of every other planet, every moon, every asteroid, and every comet in our solar system, Jupiter would still be 2.5 times heavier than all of them combined. To the human mind, Jupiter represents the absolute limit of planetary scale. It is a world of crushing gravity and continent-sized storms that have raged for centuries. But in the grand, terrifying arena of the cosmos, Jupiter is practically a grain of sand. Because hovering just across the void from Jupiter is our sun. And the gap between the largest planet in our solar system and the star that keeps us alive is a chasm so vast it almost defies human comprehension. You could fit 1,000 Jupiters inside the sun. For decades, astronomers looked at the massive gap between planets and stars, and they saw a rigid, unbreakable law of physics. The universe,
did not do half measures. You were either a planet, a cold, wandering sphere of gas and rock,
or you were a star. There was no in between. But why? What is the actual mechanism that separates a dark, freezing gas giant from a brilliant, life-giving sun? The answer comes down to one single, inescapable force: gravity. Imagine a massive cloud of primordial gas floating in deep space. Slowly, over millions of years, gravity begins to pull that gas together. The cloud collapses inward, spinning faster and faster, gathering more and more mass. As millions of trillions of tons of gas pile on top of each other, the pressure at the very center of this sphere begins to rise. And as the pressure rises, the temperature skyrockets. Deep inside the core of this forming world, it is no longer just hot. It is apocalyptic. The crush of gravity becomes so intense that the very atoms of hydrogen gas are stripped of their electrons. They are squeezed together with such violent, unimaginable force that they have nowhere left to go. They begin to collide. And then, a miracle of physics happens. If and only if this sphere gathers enough mass, the temperature at its core will hit a staggering 10 million degrees Celsius. At that exact temperature, the crush of gravity overcomes the natural repulsion of the atoms. The hydrogen atoms slam into each other and fuse together, creating helium. In that fraction of a second, nuclear fusion ignites. A burst of pure, blinding energy violently pushes back against the crushing weight of gravity. A beautiful equilibrium is reached. A star is born, and light floods out into the dark universe. This is the absolute boundary, the threshold of fire. To cross this boundary, a sphere of gas must be roughly 80 times more massive than Jupiter. If it hits that magic number, it ignites. It becomes a star. It will burn for billions of years. But if it falls short, if it only gathers 79 times the mass of Jupiter, or 50 or 20, it fails. The core never reaches 10 million degrees. The nuclear engines never ignite. The outward push of fusion never comes. Gravity wins, crushing the sphere into a dense, dark ball of gas. For a long time, we thought these failed stars, known as brown dwarfs, were simply the universe's rejects. We pictured them as tragic, glowing embers. They gathered enough mass to get incredibly hot, glowing a dull, angry magenta for a few million years. But without the engine of nuclear fusion to sustain them, they inevitably cool down, slowly, agonizingly fading into total pitch blackness, wandering the galaxy as dark, invisible ghosts. We thought we understood this cosmic purgatory. We thought we had mapped the exact threshold where a planet ends and a star begins. But the universe doesn't care about our rigid categories. Because when astronomers pointed the James Webb Space Telescope's infrared sensors toward a seemingly empty, pitch-black, a patch of the Cygnus constellation, they didn't just find another failed star. They found an object that shouldn't be physically possible. A titan hovering so close to the boundary of ignition that it threatens to tear down everything we know about how stars are born. And to understand just how terrifying this anomaly is, we have to look closely at the impossible telemetry echoing back from the Cygnus Abyss. Let's travel 133 light-years away from Earth, out past the familiar neighborhood of our local stars, deep into the northern sky, toward a sprawling pattern of gas and dust, known as the Cygnus constellation. If you were to look at this specific patch of sky with a standard telescope or even with the mighty Hubble, you wouldn't see anything out of the ordinary, just the bright, burning light of a Type A main sequence star. A star slightly hotter and heavier than our own sun, commanding a seemingly quiet, well-behaved solar system. But the James Webb Space Telescope does not see the universe the way we do. It doesn't look at visible light. It looks at heat. It peers through the thick, obscuring dust of the cosmos, using its near-infrared camera, hunting for the faint, glowing thermal signatures of objects hidden in the dark. And when astronomers recently pointed JWST's golden mirrors toward this star in Cygnus, they weren't looking for a planet. They were looking for the subtle, leftover debris of a solar system still under construction. Instead, they found a monster. Buried deep in the data, roughly 2.5 billion miles away from the host star, a distance roughly equal to where Uranus sits in our own solar system, there was a shadow. An object that was undeniably there, exerting a massive gravitational pull, carving a path through the dust, yet emitting almost no visible light. To find a planet at that distance isn't entirely unusual. But as the telescope gathered more infrared data, using a coronagraph to block the blinding glare of the astronomers realized this was not a normal planet. The numbers coming back from the sensors were completely off the charts. The object, now designated as exoplanet 29 Cygni b, was heavy, terrifyingly heavy. When scientists calculated its mass, the results stopped them in their tracks. 29 Cygni b wasn't just slightly bigger than Jupiter. It was 15 times more massive. Imagine taking 15 Jupiters, 15 colossal gas giants, each one large enough to swallow 1,000 Earths, and crushing them together into a single brooding sphere. The gravitational force of an object this massive is almost beyond human comprehension. It is a world where the atmospheric pressure would crush our strongest deep-sea submarines like tin cans in a fraction of a second. It is a world that commands so much raw material, it contains 155 times the heavy elements of our entire planet. This was not just a gas giant, it was a heavyweight, Titan. An object so massively dense, so utterly dominant in its local space, that it sat right on the razor's edge of the absolute boundary we talked about earlier. It had the exact mass required to spark the fires of nuclear fusion. It had the weight of a star. The scientists analyzing the data knew exactly what this meant. 29 Cygni b had crossed the threshold. It had mass to trigger the apocalypse at its core. It should be burning. It should be a brown dwarf, glowing with the fierce residual heat of early ignition. It should be illuminating the dark dust around it. The gravity was there. The pressure was there. The spark should have caught. But here's what the observation data didn't expect. When JWST measured the exact thermal profile of 29 Cygni b, the physics broke down. At 15 times the mass of Jupiter, the immense gravitational crush at its core should have generated a massive thermal footprint. It should be glowing with the heat of its own collapse. Instead, JWST's infrared sensors returned a temperature reading that was impossibly cold. The core wasn't just failing to ignite, it was completely, bafflingly dead. Something had drained the thermal energy of a Titan. But here's what the observation data didn't expect. When JWST measured the exact mass of 29 Cygni b, the physics broke down. At 15 times the mass of Jupiter, the immense gravitational crush at its core should have generated a massive thermal footprint. It should be glowing with the residual heat of its own collapse. Instead, JWST's infrared sensors returned a temperature profile that was impossibly cold. The core wasn't just failing to ignite, it was completely, bafflingly dead. Something had drained the thermal energy of a Titan. To truly understand why the core of 29 Cygni b is an impossible, freezing graveyard, we have to do something terrifying. We have to leave the safety of our telescope, mirrors behind. We have to plunge directly into the dark. If you were to drop through the upper cloud deck of this 15 Jupiter Leviathan, your first sensation wouldn't be heat or light. It would be absolute, suffocating darkness, accompanied by a weight that defies human experience. At the outermost edge of the atmosphere, the gravity of 29 Cygni b is already pulling it with a force multiple times stronger than Earth's. As you sink deeper, passing through layers of swirling methane and ammonia ice, the sheer volume of gas above you begins to stack. On Earth, we live at the bottom of a gentle ocean of air. The weight of our atmosphere presses down on us with a comfortable 14.7 pounds per square inch. But as you descend into this failed star, that number doesn't just increase, it compounds exponentially. Within a few hundred miles, the sky above you becomes an unyielding ceiling of unimaginable mass. The atmospheric pressure reaches thousands, then tens of thousands of times anything felt on Earth. At this depth, the distinction between a gas and a liquid completely vanishes. You are no longer falling through air. You are sinking through a dense, supercritical fluid, a bizarre, choking ocean of compressed hydrogen that has no surface and no shore. And it is here that the true meaning, the horror of 29 Cygni b's scale begins to manifest. Under this kind of apocalyptic pressure, the molecules of hydrogen gas are forced so close together that their very structures begin to distort. They are jammed into a matrix so tight that electrons are stripped away from their protons. The gas stops behaving like gas. It undergoes a terrifying phase transition. It becomes liquid metallic hydrogen. Imagine a dark, churning ocean of liquid metal, stretching for tens of thousands of miles in every direction, completely enveloping the interior of the world. This substance doesn't exist naturally anywhere on Earth. We have only ever manufactured tiny microscopic drops of it in our most advanced high-pressure physics laboratories, and even then, only for a fraction of it. a millisecond before it violently explodes. But inside 29 Cygni b, it is the dominant state of matter. This colossal sea of metallic fluid conducts electricity perfectly, generating a planetary magnetic field so immense, so violently powerful, that it would fry the electronics of any spacecraft millions of miles before it ever arrived. You are now deep inside the machine of a Titan, a place where gravity is trying with all its might to force a star into existence. Every single cubic centimeter of this metallic ocean is screaming with energy. The friction alone should be generating thousands of degrees of heat, radiating outward into the Cygnus void. As you push deeper and deeper toward the absolute center, approaching the rocky, icy core that seeded this giant billions of years ago, you expect the final definitive proof of stellar ignition. You expect the furnace. You expect the core to be a blinding, white-hot point of pure plasma. You expect the crushing weight of 15 million atmospheres. You expect for Jupiters to have forced the temperature past the point of no return. You expect a sun. But it isn't there. Instead, the deeper you go, the more the mechanical reality of this world betrays its own size. The core continues to rise into the millions of atmospheres, but the expected spike in temperature simply flattens out. The core of this monstrosity is a cold, dense, petrified lump of iron and rock, locked in an eternal frozen stasis beneath. A mountain of metallic fluid. This is the existential weight of 29 Cygni b. It is a world that possesses all the raw materials, all the structural layout, and all the crushing gravity required to become a light in the dark. It has the body of a god, but no soul. It is a massive, highly efficient engine of gravity that has been permanently stalled. And as the James Webb Space Telescope stared at this giant, cold core, astronomers were left with a haunting, unresolved riddle. What could possibly possess the power to rob a 15 Jupiter Titan of its birthright? What happened in the earliest days of Tamaris? This solar system to permanently steal the spark of a forming sun? To find out, we have to look away from the planet's interior and look closely at the violent, chaotic neighborhood where it was born. How do you kill a star before it's even born? This is the impossible question staring back at astronomers from the telemetry of 29 Cygni b. You have an object with the mass of 15 Jupiters. You have millions of atmospheres of pressure crushing down on a dense core. You have an environment so violent that it physically breaks hydrogen gas into a liquid metal ocean. All the raw, brutal ingredients for stellar ignition are sitting right there in the dark. It is like finding a colossal, perfectly engineered spacecraft sitting on a launch pad, fully loaded with fuel. Its structural integrity, flawless. And yet, the engines are dead cold. To solve the mystery of this frozen core, we have to look past the bulk mass of the planet and examine the exact microscopic mechanics of how a star wakes up. Because a star doesn't just suddenly switch on. It needs a catalyst. Earlier, we talked about the absolute boundary of light. We talked about how true stars, like our sun, are powered by hydrogen fusion, which requires a staggering core temperature of 10 million degrees to ignite. But here is the catch. A collapsing cloud of cold primordial gas doesn't just magically jump to 10 million degrees. Gravity takes time. The pressure builds slowly over millions of years. So how does a forming star bridge the gap? How does it generate enough initial mass to heat to finally trigger the main nuclear engines? It uses a starter motor. Hydrogen atoms is an incredibly rare, ancient isotope called deuterium. Often called heavy hydrogen, deuterium is a ghost from the very dawn of time. Every single atom of it was forged in the unimaginably hot, chaotic first 3 minutes following the Big Bang. It is the original fuel of the cosmos, and for a forming star, deuterium is the spark plug. Unlike normal hydrogen, deuterium is highly combustible. It doesn't need 10 million degrees to undergo nuclear fusion. It only needs about 1 million degrees. This is the vital, stepping stone process of starbirth. As a massive sphere of gas collapses and the core temperature reaches that 1 million degree mark, the ancient deuterium ignites. It flashes. This brief, violent burst of nuclear energy acts like kindling. It halts the collapse of the gas, generates a massive surge of internal heat, and pushes the core temperature rise, up, 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 until it finally hits 10 million degrees, and the main hydrogen reserves catch fire. The starter motor cranks, and the main engine roars to life. But this is where the physics of 29 Cygni b become truly terrifying. Astronomers know exactly how much mass is required to generate the pressure needed to hit 1 million degrees and ignite that deuterium spark plug. It is the most universally accepted threshold in astrophysics: 13 Jupiter masses. If an object hits 13 Jupiters, the deuterium must burn. It is an unavoidable law of thermodynamics. 29 Cygni b is 15 Jupiter masses. It passed the threshold. It had the weight. It had the pressure. Billions of years ago, buried deep inside a swirling nebula of gas and dust, the core of 29 Cygni b reached 1 million degrees. The starter motor cranked. The heavy hydrogen ignited. For a brief, fleeting moment in deep time, this dark leviathan woke up. It glowed with a dull, angry, deep red light, radiating massive amounts of heat out into the void. It was on its way. It was taking the final steps toward becoming a permanent burning fixture in the night sky. But the main engine never caught. The 10 million degree threshold was never reached. The glow faded, the heat dissipated. The core petrified into a cold, dead lump of rock and iron, and the sphere plummeted back into total darkness, never to shine again. Fall. It didn't fail because it was too small. It failed because it starved. Deuterium is only a temporary fuel. A brown dwarf can only burn it for To make the jump to a true star, the object must aggressively, violently continue feeding on few million years. The surrounding nebula, pulling in millions of trillions of tons of fresh hydrogen to pile on. The pressure. 29 Cygni b was hungry. It was perfectly positioned to devour the gas around it. Ate it and ignite into a brilliant sun. But the supply line was cut. Something or someone in the chaotic architecture of its early solar system violently ripped the food from its mouth. How does an object the size of 15 Jupiters just stop growing? What kind of unimaginable force could possibly reach into a stellar nursery and permanently stall the birth of a sun? But here's what scientists didn't expect when they tracked its trajectory backward through deep time. 29 Cygni b wasn't born in the isolated darkness where JWST found it. By mapping its rogue orbital path against the cosmic microwave background, astronomers realized this titan, it was violently ejected from a binary star, a star system in its infancy, ripped away from its feeding disk right before it could gather. The final mass needed for ignition. To answer that question, astronomers had to do something that seems almost like magic. They had to turn the James Webb Space Telescope into a time machine. When you look at a photograph of an accident scene on Earth, you can often reconstruct exactly what happened just by looking at the debris. Skid marks on a highway tell you the speed and direction of a car long after the crash is over. The universe leaves skid marks too. They are just written in gravity and momentum. When astronomers looked at the current position of 29 Cygni b sitting 2.5 billion miles away from its host star, something about the math felt fundamentally wrong. Orbits are usually highly organized. Planets that form peacefully from a flat disk of gas around a star tend to stay in flat, circular lanes, like runners on a track. They all move in the same direction, locked in a stable, predictable rhythm. But 29 Cygni b wasn't on a flat track. By taking multiple observations over months and cross-referencing its position against the static background light of distant galaxies, researchers plotted its exact trajectory, and the resulting path was violently erratic. This 15 Jupiter Titan wasn't just orbiting the host star, it was plunging in and out of the solar system's equatorial plane at a steep, wild angle. Its orbit wasn't a neat circle. It was a highly stretched, chaotic ellipse. Worse still, it was rotating on an axis that was completely tilted away from everything else in the system. It was behaving like a cannonball that had just crashed through a window. The data painted an undeniable picture. 29 Cygni b did not form in the quiet, isolated darkness where JWST found it. It is a refugee. By running incredibly complex gravitational models backward, rewinding the clock of the cosmos, Astronomers traced the Titan's wild trajectory back to its exact point of origin. They traced it back to a gravitational war zone. To understand the sheer violence of what happened to this world, we have to erase the image of the quiet, empty void we see today. We have to rewind the clock by roughly 3 billion years to the very birth of the Cygnus stellar neighborhood. When we think of a star being born, we usually picture a gentle, majestic process. A beautiful, glowing cloud of gas slowly pulling itself together in the silent dark. But the reality of a stellar birth nursery is closer to a chaotic, hyper-violent feeding frenzy. Stars are rarely born alone. The massive molecular clouds that seed them are turbulent and unstable, collapsing into dozens of gravitational whirlpools all at once. And roughly 3 billion years ago, in this exact patch of space, the cloud didn't just collapse into one star. It collapsed into 3. A multi-star system was waking up. At the center of this collapsing cloud, 2 massive cores of gas were rapidly gathering. Weight, pulling in millions of tons of hydrogen every single second. These would become the primary stars. But caught in the crossfire, orbiting dangerously close to these 2 growing monsters, was a 3rd core, the runt of the litter. Exoplanet 29 Cygni b. At this moment in deep time, 29 Cygni b was not a failed star. It was a massive, glowing, violently hot sphere of liquid metal and gas. It had already hit the 13 Jupiter mass threshold. Its ancient deuterium core had ignited. The starter motor was running. It was glowing a fierce, angry red, desperately trying to gather the final mass it needed to trigger full nuclear fusion. To survive, to become a true star, it needed a constant, uninterrupted flow of fresh hydrogen. It was feeding from a massive, swirling accretion disk, an umbilical cord of primordial gas funneling directly into its atmosphere. If it could just hold on to that disk for a few million more years, the heat at its core would hit 10 million degrees. The main engines would catch. It would become a sun. But gravity is a merciless force. And 29 Cygni b was trapped in the most dangerous mathematical trap in the universe, the 3-body problem. In astrophysics, predicting the orbit of 2 massive objects is relatively easy. A single planet orbiting a single star, or 2 stars orbiting each other, will lock into a stable, predictable mathematical dance that can last for billions of years. But the moment you introduce a 3rd massive object into the gravitational field, the math completely shatters. Isaac Newton realized this centuries ago. You cannot perfectly predict the movements of 3 massive bodies orbiting close to one another. Their gravitational fields constantly tug, pull, and warp against each other. A stable circular orbit suddenly stretches into an oval. A safe distance violently shrinks. The energy constantly shifts from one body to the other in a chaotic, unpredictable feedback loop. For 29 Cygni b, this meant its environment was a ticking time bomb. As the 2 larger sibling stars grew more and more massive, their gravitational pull became terrifyingly strong. They began to dominate the space, their invisible hands reaching further out into the gas cloud. For a while, 29 Cygni b managed to survive on the fringes. It continued to sweep up gas, growing heavier, the deuterium fires burning hot at its core. it hit 14 Jupiter masses. Then, 14.5. It was agonizingly close to the 10 million degree threshold. But the chaotic dance of the three-body problem was reaching its breaking point. The orbits of the three giants drifted out of resonance. Instead of circling each other at a safe distance, their paths began to cross. The delicate gravitational balance collapsed. Imagine standing on the glowing, turbulent surface of 29 Cygni b at this exact moment, looking up into a dark, gas-choked sky. You wouldn't just see stars. You would see two blinding, colossal walls of fire tearing through. The heavens, growing larger and larger by the second. The heaviest of the three sibling stars was swinging inward, caught in a massive elliptical dive, and it was heading directly on a near collision course with the young Titan. A young brown dwarf, dragging its metallic oceans miles into the sky. But the true tragedy wasn't the tidal wave. As the larger star closed the distance, its gravitational wave hit 29 Cygni b like a physical wall. The sheer force of the tidal pull was so immense that it physically warped the spherical shape of the Earth. It was the theft. As the larger star screamed past at millions of miles an hour, its overwhelming gravity acted like a cosmic scythe. It sliced right through 29 Cygni b's accretion disk, the massive umbilical cord of gas that was feeding our Titan. The fuel it desperately needed to ignite was violently ripped away. Trillions of tons of hydrogen were stripped from its atmosphere and devoured by the larger. In a matter of hours, the food source was gone. But the violence wasn't over. Because of the chaotic physics of the three-body encounter, energy had to be exchanged. When the massive sibling star swung past, it didn't just steal the gas. It transferred a mind-bending amount of orbital momentum directly into 29 Cygni b. It performed a gravitational slingshot. In a fraction of a cosmic second, the young, glowing Titan was kicked. Accelerated to millions of miles per hour, the 15 Jupiter sphere was violently ejected from its orbit. It was physically ripped from the stellar nursery. The gravitational tether snapped. Tossed out like a piece of cosmic shrapnel, 29 Cygni b was hurled outward, away from the warmth, away from the light, and into the freezing, empty expanse of the outer solar system. It was an exile. As the brown dwarf plummeted into the freezing dark, the tragedy of its stolen mass became absolute. It had been robbed of the final layer of gas it needed. The core, once burning with the fierce hope of a million-degree deuterium fire, had nothing to let it sustain it. With no more gas to gather, the pressure stopped rising. The temperature flatlined. Over the next few million years, a mere blink of an eye in cosmic terms, the red glow of the Titan began to fade. The heat radiated away into the unforgiving void. The liquid metal oceans cooled and thickened. The surface darkened to a deep, bruised purple, and then, finally, to pitch black. The starter motor died. The star failed. This is the gravitational war zone that the James Webb Telescope uncovered. A massive 15 Jupiter. Ghost, murdered in its infancy, forever haunting the dark edges of a solar system it was supposed to rule. But if you think a dead core and a dark sky means 29 Cygni b is a quiet, peaceful graveyard, you are gravely mistaken. Because a massive object doesn't just switch off without a fight. The heat of its violent birth may be trapped deep beneath the surface, but the energy of this titan still has to go somewhere. And as JWST focused its spectrographs on the pitch-black atmosphere of this rogue world, it revealed an environment so hostile, so utterly alien, that it makes the worst storms in our solar system look like a gentle breeze. When we hear that an object has been exiled from its solar system, that its core has died, its ignition failed, and its light extinguished, human intuition paints a very specific picture. We imagine a silent, frozen tomb. A dark sphere of gas peacefully drifting through the quiet void of deep space, locked in a state of eternal, undisturbed sleep. But the laws of thermodynamics do not allow for peace on this scale. Exoplanet 29 Cygni b may not have a nuclear furnace burning at its center, but it is not quiet, and it is certainly not dead. To understand the sheer, terrifying violence of this world, we have to look closely at what happened to all that energy from its violent birth. When 15 Jupiters worth of mass collapses in on itself, the friction of trillions of tons of gas grinding together generates a mind-bending amount of heat. During its brief, glowing phase, the interior of 29 Cygni b was practically boiling. And when the Titan was kicked out of its solar system, that heat didn't just instantly vanish into the vacuum of space. Space is a vacuum, which means it is actually an incredibly efficient insulator. There is no air, no medium for the planet's internal heat to easily conduct into. The heat is trapped. Deep beneath the crushing metallic oceans of 29 Cygni b, thousands of miles down, the ambient temperature is still hovering around 50,000 degrees Fahrenheit. It is a sealed pressure cooker. And because heat must rise, this trapped apocalyptic thermal energy is constantly trying to claw its way up
To the surface.
Meanwhile, the very outer edge of the atmosphere is exposed to the absolute zero of deep space.
It is unimaginably cold.
When you have thousands of degrees of heat rising from the bottom, slamming into a ceiling of freezing, deep space cold at the top, you create something meteorologists call a convection gradient. On Earth, convection gradients are what drive our weather. The sun heats the ground, the warm air rises, hits the cold upper atmosphere, condenses, and creates thunderstorms. But on Earth, our weather is driven by a gentle temperature difference of maybe a few dozen degrees. On 29 Cygni b, the temperature difference between the core and the void is tens of thousands of degrees. Degrees, multiplied by the crushing gravity of 15 Jupiters. The result is a planetary weather system so hostile, so utterly chaotic, that it challenges the very limits of fluid dynamics. Let's start with the wind. On Earth, a Category 5 hurricane, the most destructive force of nature we experience, generates wind speeds of roughly 120 miles per hour. 150 miles per hour. At that speed, the air itself becomes a blunt weapon, capable of tearing the roofs off houses and leveling forests. On 29 Cygni B, a wind speed of 150 miles per hour would be considered a dead
I feel so relaxed right now. I guess I did need to take a break.
Because this planet doesn't have a solid surface to slow the air down with friction, and because the massive thermal updrafts are constantly churning the atmosphere, the winds are caught in a permanent runaway feedback loop. Furthermore, despite its colossal size, the Titan is spinning on its axis at a terrifying rate. A day on this giant lasts only 3 hours. This hyper-rotation creates a Coriolis effect that shreds the atmosphere into massive, supersonic jet streams. We are talking about horizontal shear winds screaming across the pitch-black sky at over 6,000 miles per hour. At 6,000 miles per hour, the wind is moving faster than a hypersonic missile. The sheer kinetic energy of the gas moving at that speed generates so much friction that the atmosphere literally howls. If you could somehow survive the pressure and float in the upper cloud deck, the sound alone would be a deafening, continuous roar of breaking sound barriers echoing across a dark, bottomless ocean of gas. But the wind is just the beginning. The true nightmare of 29 Cygni B is what those winds are carrying. Because of the extreme temperatures welling up from the interior, the chemistry of the atmosphere is completely alien. On Earth, our clouds are made of water vapor. But deep in the atmosphere of this failed star, the heat is so intense that rock and metal cannot exist as solids. They are vaporized. The clouds of 29 Cygni B are made of vaporized rock. Imagine a storm front rolling in, but instead of dark gray water clouds, it is a towering, churning wall of liquid silicates. Liquid glass and sand, suspended in the supersonic winds, rubbing together with unimaginable kinetic force. When these silicate clouds rise high enough into the atmosphere, they hit the freezing boundary of deep space. The vaporized rock rapidly cools. It condenses. And then it begins to rain. A rainstorm on 29 Cygni B is an apocalyptic event. The droplets falling from the upper atmosphere are not soft beads of water. They are sharp shards of cooling glass and heavy, molten flakes of rock plunging downward under the pull of a gravitational field dozens of times stronger than Earth's. But as this rain falls, it encounters the ultimate contradiction of this world. The deeper it drops, the hotter it gets. Hundreds of miles below the silicate cloud deck, there is a second layer of weather. A heavier, darker, and far more violent weather system. Down here, the pressure is immense, and the temperatures are hovering around 4,000 degrees. At this exact temperature and pressure, iron vaporizes. Below the raining glass, there are continent-sized storm systems made entirely of vaporized iron. And just like the rock clouds above, when the thermal updrafts push this iron vapor slightly higher, it cools and it condenses into liquid. It rains liquid iron. Imagine floating in the pitch blackness of this secondary cloud deck. You cannot see your own hands in front of your face. The roaring of the supersonic winds is absolute. And falling all around you, streaking through the dark, are massive, heavy droplets of molten liquid iron, glowing with a faint, angry red heat. Because the gravity is so intense, these iron raindrops don't fall at terminal velocity like they would on Earth. They are dragged downward at hundreds of miles per hour, slamming into the denser layers of gas below, like artillery shells. We have a name for this cycle. Astronomers call it a metallic hydrological cycle. The iron rains down, falls into the deep, superheated interior, vaporizes back into gas, and violently boils. Back up to the surface to form new clouds. It is a permanent, unbreakable loop of boiling, raining, and vaporizing metal. And where you have massive, heavy clouds of different materials aggressively rubbing against each other in supersonic winds, you get static electricity. On Earth, the friction of water crystals inside a thunderhead generates a static charge that eventually discharges as a lightning bolt. A powerful lightning strike on Earth carries about 300 million volts of electricity and heats the air to 30,000 degrees for a fraction of a second. The electrical storms inside the clouds of 29 Cygni b are of a magnitude that breaks standard meteorological models. When continent-sized clouds of liquid glass grind against fast-moving jet streams of molten iron, the static charge that builds up is planetary in scale. The atmosphere becomes a giant, supercharged capacitor. When the atmosphere finally discharges, the lightning bolts are thousands of miles long. They do not just crackle, they tear the atmosphere apart. The energy release is so violent that it briefly superheats the surrounding metal clouds into pure, blinding plasma. This is the only light on 29 Cygni b. If you were suspended in this atmosphere, the total, suffocating darkness would be shattered every few seconds by blinding, terrifying flashes of blue-white electrical fire, illuminating towering, churning walls of iron clouds stretching endlessly into the abyss. It is a strobe-lit descent into hell. Because 29 Cygni b has no solid surface to break up these weather systems, the storms do not dissipate. On Earth, a hurricane dies when it hits land. Here, there is no land. The storms are immortal. Over millions of years, these iron hurricanes and silicate jet streams organize themselves into semi-permanent structures. Gas giants don't have geography in the way we do. They don't have mountains or valleys. Their geography is made entirely of weather. If you could view the planet under special thermal imaging, you wouldn't see a uniform sphere. You would see distinct, violent bands of dark reds and deep purples separated by sheer walls of high-pressure wind. You would see massive, swirling vortexes, cyclones the size of 3 Earths churning with liquid metal, diving deep into the planet's interior and dragging boiling material back to the surface. It is a world whose very geography is trying to tear itself apart. For years, astronomers could only guess at this nightmare. We knew from the laws of physics that a brown dwarf of this mass should have this size kind of weather. We had complex computer models that predicted the iron rain and the supersonic winds.
But they were just models.
An educated guess about a dark world we could never truly see. Then, the James Webb Space Telescope arrived. JWST was not built to look at visible light.
It was built to see the invisible.
It was built to read the subtle infrared heat signatures of the universe. And when astronomers pointed its incredibly sensitive spectrographs at 29 Cygni b, they weren't trying to take a picture of the planet. They were trying to read the barcode of its atmosphere. Every chemical element in the universe absorbs and emits light in a highly specific way. It acts like a fingerprint. If you look at the light bouncing off or radiating from a planet's atmosphere and you split that light through a prism, you will see tiny, dark gaps in the spectrum. Those gaps tell you exactly what chemicals are present in the air. Usually, to read the atmosphere of an exoplanet, scientists wait for the planet to pass in front of its host star. The starlight shines through the edge of the atmosphere, acting like a giant cosmic backlight, allowing us to read the chemical barcode. But 29 Cygni b is unpredictable. It was kicked out. It is billions of miles away from its star, drifting in the dark. There is no backlight. To read its weather, JWST had to rely entirely on the planet's own internal heat. It had to catch the faint, deep infrared glow of that trapped 50,000-degree core as it slowly filtered up through the cracks in the churning iron clouds. It was like trying to read the manufacturer's label on a light bulb by the light of a single glowing ember locked inside. It took weeks of observation time, staring deep into the Cygnus constellation, gathering photon by agonizing photon. The researchers analyzing the data expected exactly what we just described. They expected the spectrograph to return the harsh, jagged chemical signatures of a violent, dead world. They expected to see the definitive proof of vaporized silicates, atmospheric iron, and heavy, crushing methane ice. They expected the data to confirm that this failed star was nothing more than a colossal, chaotic blender of molten rock and metal, an environment so hostile that any complex molecule would be instantly shredded by the sheer kinetic and thermal violence of the storms. And at first, the data confirmed exactly that. The signatures of liquid iron and silicate clouds were undeniable. The models were right. It was a nightmare world. The scientists were preparing to publish the findings. A complete, terrifying meteorological profile of a rogue titan. A perfect, textbook example of a brutal, sterile brown dwarf atmosphere. They thought they had 29 Cygni b completely figured out. But here's what the James Webb Telescope didn't expect to find hidden inside those molten silicate clouds. When researchers ran the final deep infrared atmospheric spectra through the latest models, looking at the very faintest thermal leaks coming from the upper atmosphere, the light signatures spiked in a way that defied the laws of chemistry. In an environment of screaming 6,000-mile-per-hour winds, bombarded by iron rain and superheated by apocalyptic lightning, the chemical bonds of complex molecules should be instantly torn apart. The environment is a molecular shredder. Yet buried deep in the spectral barcode of this failed star, JWST detected something impossible. It detected the heavy, undeniable signature of complex, carbon-rich molecules. The fundamental building blocks for complex chemistry, surviving and somehow stabilizing in the most hostile, unlit, violent environment imaginable. And to understand what that actually implies, we have to look at what might be orbiting in space, the dark just beyond the reach of those storms. But here's what the James Webb Telescope didn't expect to find hidden inside those molten silicate clouds. When researchers ran the atmospheric spectra through the latest models, the light signature spiked in a way that shouldn't be possible in a chaotic, iron-raining atmosphere. JWST detected complex carbon-rich molecules, the fundamental building blocks for complex chemistry, surviving and perhaps thriving in the most hostile, unlit environment imaginable. When astronomers first saw the spectral signature of complex, carbon-rich molecules buried in the hostile atmosphere of 29 Cygni b, they were forced to confront a profound contradiction. Carbon chemistry is delicate. The molecules required to build the foundation of complex, interactive systems, the very precursors to life as we understand it, require stability. They need a quiet, temperate environment to bond, grow, and interact. They do not belong in a churning, 50,000-degree atmospheric blender of vaporized iron and supersonic glass rain. If those molecules formed directly inside the atmosphere of the brown dwarf, it implies that our understanding of extreme chemistry is fundamentally flawed. It suggests that complex systems can self-assemble inside the engine of a nightmare. But there is a second, far more haunting possibility. What if the carbon signature that the James Webb Space Telescope detected wasn't coming from Earth? What if it was bleeding into the atmosphere from somewhere else? To answer that, we have to remember what happened 3 billion years ago. When 29 Cygni b was violently kicked out of its stellar nursery, it was a fully formed 15 Jupiter Titan. And an object with that much immense gravity does not travel through the universe alone. When a gas giant forms, it generates its own localized disk of debris, a warm version of the stellar nursery it was born in. Over millions of years, that debris coalesces. It builds rocks. It builds worlds. When 29 Cygni b was ejected into the freezing void of deep space, it didn't leave empty-handed. Its gravitational grip was so unimaginably strong that it took its immediate surroundings. It dragged an entire system of moons out into the dark. Try to picture the architecture of this dark solar system. You have a central anchor, a brooding, storm-ravaged Leviathan, drifting through the absolute zero of interstellar space, completely disconnected from any star. Orbiting this Titan are moons, but these are not like Earth's moon. They are not bathed in the warm, golden light of a sun. From the surface of these rogue worlds, the sky is perpetually, suffocatingly black. There is no daytime. There are no seasons. By all standard logic, a moon trapped in the interstellar void should be a dead, frozen sphere of solid ice, chilled to nearly -400 degrees Fahrenheit.
But gravity is a substitute for sunlight. Because 29 Cygni b is so massive, its gravitational pull on its moons is violently uneven. As these moons orbit the giant in highly elliptical, chaotic paths, the gravity constantly stretches and compresses them. It physically kneads the solid rock of the moons, pulling their cores out of shape and letting them snap back. This process is called tidal heating, and the friction it generates deep inside the crust of these moons is staggering. The surface of these moons might be encased in miles of pitch-black ice, but beneath that ice, the tidal friction melts the rock. It creates global, subsurface oceans of liquid water kept boiling hot by deep-sea hydrothermal vents. It is an environment rich in heat, rich in liquid, and completely shielded from the radiation of deep space.
It is a sanctuary.
If complex, carbon-rich chemistry is happening anywhere in the Cygnus Abyss, it is happening down there, in the dark.
Crushing depths of an alien ocean, orbiting a failed star.
And occasionally, the violent tidal forces squeezing these moons become too much. The ice crust cracks open. Massive, towering geysers of water, steam, and complex carbon molecules erupt into the vacuum of space, trailing behind the moon like a cosmic tail. That tail gets swept up by the massive gravitational well of the brown dwarf. It gets pulled down into the iron clouds. If this theory holds true, then the James Webb Space Telescope didn't just detect anomalous chemistry inside a planetary storm. It detected the chemical exhaust of a hidden, lightless ocean. Imagine standing on the cracked, icy surface of one of those moons. You are standing in absolute darkness. The ground beneath your boots is trembling, humming with the violent thermal energy of the deep ocean, churning miles below. And when you look up into the sky, there is no sun to blind you. Instead, covering half the sky is the crushing, colossal mass of 29 Cygni b. It does not shine, but you can see it. You can see it because every few seconds, the dark expanse of its atmosphere violently erupts with planet-sized webs of blue-white electrical lightning, illuminating the towering iron clouds and casting long, terrifying shadows across the ice of the world you are standing on. It is a completely self-sustaining, violently active solar system operating in total secrecy, billions of years, miles away from the nearest star. And the terrifying truth is, 29 Cygni b is not unique. We have spent thousands of years looking up at the stars. We mapped out the constellations. We counted the burning suns. We thought the light told us the whole story of the universe. It didn't. Exoplanet 29 Cygni b is not just an anomaly, it is a warning. The James Webb Space Telescope has proven that our models of galaxy formation are fundamentally incomplete. The darkness between the stars isn't empty, it is crowded. For every star that ignited and pushed back the dark, there could be a dozen failed titans drifting silently through the void, invisible to our eyes, undetectable to our older telescopes. The mass of our galaxy is hiding in plain sight. Millions of rogue worlds, failed suns, and dark solar systems, completely untethered from the light. 29 Cygni B proves that the boundary between a planet and a star is not a clean line. It is a violent, chaotic battlefield, and the universe is littered with the casualties. We are floating through a graveyard of stars that never woke up, and they vastly outnumber the lights we see in the sky. When you step outside tonight and look up at the black gaps between the stars, it feels different now, doesn't it? That darkness isn't a void anymore. It's a hiding place. Somewhere out there in the pitch black of the Cygnus constellation, a colossal sphere of turbulent gas and molten iron rain is silently making its way through the deep. It will never shine. It will never warm a sunlit world. But it is there. A monument to the brutal, unforgiving physics of the cosmos. It makes you wonder about the moons that might be caught in its gravity. Worlds locked in eternal night, heated only by the violent churning of the Titan they orbit. What kind of strange chemistry, what kind of undiscovered phenomena might be unfolding in a solar system that has never seen a single ray of sunlight? If you were standing on the surface of a moon orbiting 29 Cygni B, what do you think you would see when you looked up into the sky? Let me know your thoughts down in the comments. I read every single one of them. The universe is far stranger and far darker than we ever imagined. And as the James Webb Telescope continues to pull back the veil, we are going to be here, exploring every terrifying, beautiful mystery it finds. Keep looking up.